Okay, we are still determining if Rolle's theorem can be applied, and then if it does, use it. Okay, so for f, or for part C on this function f, is it continuous and differentiable in this interval? Well, it's definitely not continuous. So if it's not continuous in there, the theorem doesn't apply. So even if one of those criteria doesn't hold, then the whole thing is a bust. Okay, now g, or for function g, g is continuous. You can plug anything you want into cosine. And its derivative is sine. You can plug anything you want into that. So it's continuous and it's differentiable. G of negative pi over 4 does actually equal g of pi over 4. And they both come out to 0. Okay, so it's continuous, it's differentiable, f of, or g of a equals g of b, so now you get to actually use the theorem. So find the derivative. So that would be a negative 2 sine of 2x. Set that equal to 0 and then solve for x. So x would equal negative pi over 2, 0, and pi over 2, but you only need to worry about solutions that fit inside the interval, which is just as x is equal to 0. Okay, so that is Rolle's theorem and how to see if it applies and then how to apply it. So the second part is on the mean value theorem. So let's kind of plot that out and see how that works. So we're going to plot these 2 points, kind of like what we did before, but one of them has a different y value. Okay, so 2, 1, 5, 3. So those are our 2 points. So draw the graph of a non-linear differentiable function that starts here and ends here. So we can't draw a line. We've got to draw something else. So let's just go like that. Okay, so then draw a line through those 2 points. So the 2 endpoints. It's kind of missed. Oh well. Let's make a bigger dot. Okay, so let's read over what the theorem says before we kind of analyze this out. So the mean value theorem says that if f is continuous on the closed interval from a to b and differentiable on the open interval from a to b, then there exists a number c in the open interval such that f prime of c is equal to f of b minus f of a all over b minus a, which should kind of make sense as to this little theorem right here, because we've been saying it all along. What is it? I keep asking the question over and over again. What is a derivative? And if you were all in class, you would say in unison, the slope of the tangent line. So here we just have said the derivative is the slope. Okay, so looking at our graph, does this theorem actually apply? So what the theorem is really saying is like, all right, if you found the line through the 2 points and then found the slope, there has to be at least one place where the tangent line on the curve would be parallel to the line through the 2 points. And on this graph, there's actually 2. I think there's one like right about there. And another one probably about right here or so. So these 2 red lines are parallel to the green one, so these 2 places have the same slope are these two places where the derivative on the curve has the same slope as the green line. So looking at our graph, does it apply? Why, yes it does. So drawing the tangent lines, that's what we just did in red. All right, let me stop the video on this one since the last one was kind of lengthy, and we'll look at how to apply the theorem and how to solve it.